In this video, I'd like to talk about the idea of radians and degrees. And you can see that I've drawn this circle here centered at the origin. And the reason I drew this is that we can draw a triangle within this circle, or we can draw really any triangle in a circle. And I'm just going to draw this right triangle here. And essentially, we're concerned with what this angle here, theta, is. And the way that we're used to measuring angles is in degrees. So if it was a flat triangle, that would be a 0-degree angle. But as we increase theta, like let's say we go to here, which is what we call a right angle, right there, and that would be a 90-degree angle. If we go all the way to this line, essentially, that would be a 180-degree angle. And if we went all the way around the circle, that would be a 360-degree angle. So the angle runs from 0 degrees to 360 degrees. And essentially, if you think about it, where if you're standing looking straight forward and you spin 360 degrees, then you end up just looking straight in the direction that you started with. So a 360-degree rotation is just spinning around in a full circle. So up until this point, you may have developed some familiarity with degrees, but degrees are not necessarily a natural measure. We, in reality, could have said that degrees run from 0 to 100 if we wanted, but through essentially arbitrary means, it was chosen to be 360 degrees. But in reality, there's a much more natural way to measure degrees. And the way we want to do that is using a concept called radians. And you may guess from just looking at the word radians that it's going to involve the radius. And essentially, if we call the radius of the circle r, then radians, instead of looking at this angle in degrees, they're instead going to ask, what is the length of this arc of the circle here? So we can measure essentially this angle in terms of how far along the arc of the circle our point essentially is. And when we've gone exactly one radius length along the arc, so whatever this radius is equal to, whenever we go that length along the arc, we call this angle, so right here, this angle would be 1 radian. And our question essentially becomes, how many of these radians would fit all the way around the circle? And so essentially, we're wondering what would the arc length all the way around this circle be in terms of the radius. And you can essentially see you go 1 radian here, you would go a second one there, a third one there, and you just keep going. And essentially, if we want to know the length around this arc of the circle, we would just use our circumference formula. Remember, the circumference is just 2 pi times the radius. So when considering how many radians are all the way around the circle, we would say there are 2 pi radians. So when theta is that 360 degrees, this would be equal to 2 pi radians. Since when the arc of the circle was one radius length, we called that angle 1 radian. And essentially, we went 2 pi times the radius all the way around, or we went 2 pi radii all the way around, or 2 pi radiuses, however you want to say it. And so essentially, if we're asking how many of these radius lengths can we fit all the way around, well, there's 2 pi of them. So essentially, the main conclusion from this is that 360 degrees is the same thing as 2 pi radians. So with this in mind, you can also figure out essentially simpler angles. Like let's say we want to go just halfway around the circle. Well, if it's 2 pi to get all the way around, then this would just be an angle of pi radians. And you can usually write it with just RAD. And if we want to go just 90 degrees around the circle, that would be pi over 2 radians. Or in other words, if we want to write that down, we know that pi radians would be 180 degrees. We're essentially just cutting each of these in half. And we know that pi over 2 radians would be 90 degrees. So it's often helpful to know these very key values to be able to convert between radians and degrees. But with all of this in mind, let's start looking at a couple different example problems.